Which of the following is not a unit of power? A. Watts, B. Joules per second, C. Kilograms times meter squared per second, or D. Kilograms times meter squared per second squared? Right off the bat, it's important to recognize that the simplest unit used to quantify power is the watt, which shows up here in answer choice A. So we can go ahead and mark off answer choice A. But what is a watt anyway? Dad jokes aside, answering this question will require us to break power down into its fundamental constituents, a useful task which should facilitate a deeper understanding of the notion of power itself. From a physics perspective, power is explicitly defined as the rate at which energy is transferred from one system to another. A definition you may be more familiar with is that of power being work divided by time. Either way, both work and energy are always going to be represented by joules, whereas the fundamental measurement for time is seconds. This allows us to go ahead and eliminate answer choice B. Just like we were able to break watts down into joules per second by considering the work divided by time equation for power, the same reductionist approach can be applied to the joule. Take the work equals force times distance equation, for instance. Since joules are the units of work, this equation lets us break joules down into newtons and meters, which are the units for force and distance, respectively. Therefore, we can now state with confidence that power can also be represented as newtons times meters divided by seconds. Just like watts, which are really a pen name for joules per second, and joules, aka newton meters, newtons can also be distilled into component pieces. In a twist of irony, we'll use the first law proposed by none other than Sir Isaac Newton himself to take apart his namesake. Newton's first law states that force equals mass times acceleration. Therefore, we can replace newtons in our reductionistic power equation with kilograms and the units for acceleration, which are meters per second squared. Nevertheless, many students may find the notion of acceleration to be a bit uncomfortable. Fortunately, acceleration can be broken down further still into change in velocity per time, the units of which are meters per second, velocity, per second, or in other words, meters per second squared. Either way, our power equation, which started out as watts and was then broken into joules per second, then newton meters per second, has finally reached the end of its reductionist road in the form of kilograms times meters per second squared times meters, all divided by seconds. If you look closely, you can see the emergent parts, newtons, joules, and ultimately watts, staring back at you. Finally, when these fundamental units are cleaned up and consolidated, we end up with kilograms times meters squared divided by seconds cubed, which is consistent with answer choice D. Therefore, the only answer choice which does not simplify out to watts, the simplest representation of power, is answer choice C, our final answer.